Our project is a fixed wing unmanned aerial vehicle. It is a high range and a long endurance rotorcraft. The main speciality of our model is that it has a dropping mechanism which allows our UAV to be used for emergency logistics or may be used for normal logistics also. Let me introduce our team. From the left, we have Sumit, next Yashas, next Siddharth Gole, next Lishika, next Pankti, and then Soumya. We all as a team work together to make the UAV a reality.
The propellers are made of glass fiber nylon with a 10-inch blade and 4.5 mm pitch. The ESC is rated at 30 amps and operates from 11.1 volts to 11.7 volts. We are using a 11.1 2200 mAh lithium polymer battery with a high energy density.
We have used servo motors to operate flight controls, which are yaw, banking, and pitch, by connecting to the rudder, aileron, and elevators. These small motors operate under 3 to 7.2 volts by giving out 1.2 kg per centimeter torque. This weighs around 9 grams. And for to propel our aircraft, we have used a 1400 brushless motor with efficiency of 78%. This operates at 6 to 12 ampere by connecting to a LiPo battery. This gives around 70 to 1000 grams of upward thrust. Another specification about this is that it weighs around 72 grams.
For our project, we have used FlySky RC Control. FlySky is a remote control system designed for the use with radio control model vehicles and drones. FlySky controllers typically use a 2.4 GHz radio frequency to communicate with the model or the drone. The controllers features various channels which allow for control of different aspects of the model such as the throttle, steering and auxiliary functions. It also offers software for programming their controllers such as the FlySky data cable and the FlySky USB flight simulator adapter. These tools allow users to customize their controller settings and simulate flying conditions on a computer. In our case, we have used the fifth channel for controlling our dropping mechanism.
It gives faster responses, efficient use of resources, and improved access to remote areas. It is used in emergency situations, battlefield, and also used for faster transportation of medical supplies.
So the conclusion is that we aim the completion of our mock project at bare minimum resources. This project aims at faster delivery using long-range, high-speed, remote-controlled planes. This can be used to deliver blood and medicines for patients in remote places and also for supplying rations, ammunition, and medical supplies in war zones. Some applications also include faster transportation of medical supplies to remote areas, supply of rations and medications to soldiers in battlefields, dropping of ammunition and bombs without pilot being in the aircraft, faster delivery of essential items in urban areas where road delivery takes time.